All right, guys. Okay, so this little study guide, you should have already done it, or maybe you're doing it while, or maybe you're going to pause it before I go over each one. This is basically the formative. I basically looked at the formative this morning and just kind of took the questions. I didn't take them exactly. Now maybe some of them are, but for the most part, I just kind of picked and chose what I wanted to go over, and that's that. So if you're getting these right, you're gonna do fine on the formula or on the formative. Okay, so we'll start with number one. Again, you should have already done number one, so you should be just grading yourself every single time. Okay, so this first one, you're going to be identifying the base shape, and then you're going to classify it. Okay, the first thing I always look for when I'm identifying 3D objects is I ask myself, is there anything being stretched? That's kind of where I start when I'm trying to figure it out. And the first thing I notice is, yes, there's a triangle being stretched from top to bottom. So right away, since there's something being stretched, I know this is a prism. Okay? Then you ask yourself, what is being stretched? Okay? What is being stretched? Those are that's like question number one and question number two. If it is being stretched, that is. What is being stretched? Well, I can clearly see that that is a triangle being stretched. So, triangular prism would be the shape. Okay? The base shape then would be, obviously, a triangle. Okay? So that answered the two questions. We kind of did it backwards. Okay? But it doesn't matter how really you do it. Those are your two answers. So if you didn't get that one right, make sure you put an X through it. Okay? If you got it correct, go ahead and check mark it or do whatever you want. Okay? Next one. Same thing here. Identify the base shape and then classify it. Well, I know right away that I see a rectangle being stretched. Now, it doesn't matter what... I guess I should have started with my questions. Is there something being stretched? Yes. If so, what? Well, rectangle. So I know this is a rectangle prism. I guess I should have written rectangular prism, but regardless. Okay? And then I know that any of these could be the base shape. My base shape is a rectangle. Okay? So there, again, make sure you mark it right or wrong. Okay? Determining whether it's a surface area problem or a volume question. Okay? Okay, remember, surface area, some key words, cover, wrap. I don't want to say the word paint because, if I said paint in a can, that's volume. But if I said painting a wall, that is surface area. So I don't want to say paint, but anytime you're doing something to just the surfaces only and you're not focusing on filling an object or whatever. Okay, cover, wrap, outside would be another little key word. Now for volume, we said fill. Amount, usually, amount, yeah, we can put that, I think. Like the amount of water in a swimming pool, that kind of stuff. The amount of whatever. Anytime you hear how many cubes, I guess I should put squares here. Squares would be 1 by 1 squares. Cubes would be 1 by 1 by 1. Okay? Any of those words will help you remember that. Remember, the amount of space something takes up. Okay, I don't remember where I left off. Anyway, you should have gone through here. Wrapping a present, again, you're putting something just simply on the surfaces of the object. So that would be obviously surface area. The amount of 1 by 1 squares that cover, there's two keywords right there. It's going to indicate surface area. And the amount of water that will fill a swimming pool, definitely going to be volume. Now, just a quick reminder, you didn't have to do this, but I'll just do it. You didn't have to, but you could add it on there if you'd like. Surface area, right up here. Surface area are always units squared, so that could be inches squared, feet squared, miles squared, centimeters squared. Okay, area is always with square units because there are 2 dimensions. Volume, on the other hand, is always cubed. Centimeter cubed, meter cubed, feet cubed, inches cubed, whatever. Okay? Alright, let's go down here, finding the volume. This is where the bulk of the video is going to take up because this is what you guys struggle with the most. Okay? So, step number 1, guys, and I really want you to do this, and some of you still don't, but it's going to really benefit you. When you get a rectangular prism, go through and put all your lengths on there. Okay? Since I know that this right here is 8 right there, I know that this also would be 8. I know that this also would be 8. And I also know there'd be a side in the back there that would also be 8. Now, you don't have to write that on there. Okay? But just know that there would be 4 edges that are 8. Okay? I know that this is 2. I know that this is 2. And you don't even have to put centimeters because it just takes up more space. Okay, but you know 2, 2, 2, and then you know this is 12, and this would be 12. That's going to really benefit you guys. Okay, do it, please. Okay, now we start the problem. First of all, we got to understand this formula. I'm going to go over it again. Okay, you should have written it. If you didn't write this formula, mark it wrong or put an X right here. Okay, all right. We got to understand that the big B, capital B, stands for the area, and you may want to write this if you don't know it, the area of the base shape. Okay, whatever that base shape is. The base shape here is different than the base shape here. Okay, remember, it's the one being stretched. Where the height, then, is the distance between the bases. Whatever you call your bases. So whatever you want to call your base. If you want to call the right side your base, that's fine. Call the right side your base. If you want to call the left side your base, that's fine. Call it. I don't care. I personally would tell you guys that it's easiest if you just refer to your base as the front in a rectangular prism. Now, you don't have that kind of choices when you have a triangular prism. You have to use the triangle, whatever side that is, whether it's the top, the bottom, the right side, the left side, doesn't matter. Okay, but I'm going to call this my front. I'm going to call that my base. So my bases here are front and back. Okay, so now we're ready to plug in. Okay, I know that that's a rectangle, so I know the area of my front is 8 times 12, okay, which is 96. That's just big B, the area of just the front. Now I've got to multiply that by the distance between my two bases, which are my front and back. So it's 96 times 16. Get out my calculator. Oh, whoops, I didn't mean to do that. Sorry. So 96 times 16. Whoops, what am I talking about? This should have been 96 times 2. Sorry, I hope I'm not confusing you. My mistake. Okay, again, let me repeat that so I'm clear. I needed to find the area of the front, because that's what I called the base. That would be 12 times 8, which is 96. So the area of the front equals 96 centimeters squared. Okay? Then I'm going to multiply by the distance between the two bases, which is times 2. Okay? So now I'm ready to do 96 times 2. That's going to give me 192 centimeters cubed. So the 3 points, number 1 would be the formula. Number 2 would be the answer. Number 3 would be the units. So give yourself, if you missed any of those 3 highlighted parts right there, it is wrong. Count it wrong. Now, if you had all 3 of those parts, count it correct. Okay? Number 3, or whatever number this is, but I don't think the numbers are right. Okay, we start here by, again, I think it's really, really beneficial. Okay, you don't really know this. You can't even do this one. I hope maybe you guys caught this. You didn't know this distance, so you really can't even do this. That was my mistake. So this should be 13 millimeters right there, that slant. So that would mean this was 13. That would mean this is 12. Okay, sorry about that. All right, so now we start with, I'm sorry. Geez, I'm making all kinds of mistakes. I'm really, really sorry. That's if you're doing surface area. That's why I had this one on here. Okay, anyway, volume. So you're going to write the formula first. Volume equals the area of the base times the distance between the two bases. Okay? Now, you got to make note here. Look at my base shape. It's a triangle. So right away, I know that I must use this formula when finding the area of my base shape. You can't just pick and choose, I'm just going to call this top my base. No, it doesn't work that way for rectangular prisms. Or I'm sorry, triangular prisms. It does for rectangular prisms. All right? So I got to find the area of my base shape, which is a triangle. So it's going to be 1/2 times my base and my height of it, which is that by that, 9 times 11. Okay? And then we're going to multiply it by the distance between the two bases, which is 12. Okay? So you get out your calculator. Again, I'm going to use 0.5 for 1/2, but it doesn't matter. Same difference. Times 9 times 11. Okay, that's going to give me 49.5. Okay, and then I'm going to multiply it by 12. And that's where I get 594 millimeters cubed. Okay, again, your 3 points. Formula, answer, units. By the way, if you did not use a capital B, it is wrong. You must use a capital B. So again, if you didn't have all three of those points, mark it wrong. Okay. Last one here. Volume equals area of the base times the height. Okay. Again, you know what? Just to switch it up, I'll just show you that it doesn't matter. I'll use my right side as the base shape this time. Okay. So I know that this is going to be to find the area of the right side. So I'm going to call this my base. The area of the right side is going to be 9 times 7. Now, what's the distance between the right side and the left side? It is 13. So it's going to be 63 times 13, which is 63 times 13 equals 819 inches cubed. There's your volume. So the 3 points, formula, answer, units. Cubed. Remember, volume is cubed. It's the area of the base shape times the distance between that base shape. Okay? All right, now surface area, okay? Now, this is the one we worked on today that some of you were starting to kind of get the hang of, I think. You're starting to get better at it. But this is a rectangular prism, so I know that it has 6 sides. This is also a rectangular prism, so I know it has 6 sides. This is a triangular prism, so I know it only has 5 sides. You need to know that. Okay, that's a big difference. So here, any rectangular prism, you can just give them the name front, back, right side, left side, top, and bottom. Okay, so the first thing I'll kind of shade in green. Let's go ahead and do the area of the front and the back. There it is. So I got to find that area. Okay. Now, if you didn't do so, do it now. You need to go through and put all your lengths on. I know that this will be 5. This would be 5. That's the thickness of the rectangular prism. Okay. This here would be 7. This would be 7, 7, 7, and 7. And then this would be 13. This would be 13. Okay. So to find the area of the front, I just got to look at my rectangles. I know that it is 13 by 7. Okay. Get out my calculator again. It's going to be 13 times 7. I know that the area formula of a rectangle is base times height. So there's where I get 91 centimeters squared. Now, it's unnecessary that we calculate the backside area because I know it's going to be the same, 91 centimeters squared. Okay. Right side, it's this by this. So I'm going to highlight it in red there. Okay, so my base and my height is 5 times 7. So that is 35 centimeters squared. Left side would also be 35 centimeters squared. By definition of a prism, opposite sides are, or definition of a rectangular prism, the opposite sides or the opposite faces are congruent, the same area, same size in every way. Okay, so now the top and the bottom, I'll shade that and let's just do yellow. Okay, so I know that I need this dimension by this dimension, so it's going to be 13 times 5. So 13 times 5 is going to give me 65 centimeters squared, 65 centimeters squared. And then at this point, all we're going to do is we're going to add up all of our areas. So, pretty easy. 91 plus 91 plus 35 plus 35 plus 65 plus 65, 382 centimeters squared. We actually had that one on the work today. Make note, 3 points of work here. You had to have all of this work. If you don't, it's going to be wrong. Okay. Second part, the answer, 382. And then, of course, area is always square units, so you must do that. Okay. Let's do this one. This is also a rectangular prism. So right away, I know that this has a front. I know it has a back. I know it has a left side. I know it has a right side. I know it has a top. I know that it has a bottom because it's a rectangular prism. Not going to be the same for this one over here. So again, let's go through and put our dimensions on there. I know that this is 6. Hang on. Okay, sorry, another interruption. But anyway, you should have went in there and you should have put all your dimensions in here. Always do that because that's really going to help you. Trust me, it helps you really see the base and the height. I think it really, really helps. Okay, and I think you guys all can do this. It's just when you try to skip that step is when you begin to struggle. So the front here, I'll highlight it in red. I'm going to do base times height. 8 times 6 I know is 48 feet squared. I know that my back is also going to be the same, 48 feet squared. Okay. I know that the right side is going to be, highlight it in green, it's going to be 17 by 6. So maybe you need to calculate that. That's okay. 17 times 6 equals 102. So I know that the left side and right side are both 102 feet squared. And then the top, which I'll highlight in blue, I know is going to be 8 by 17. Okay, so 8 times 17 is going to give me 136 for both of these. Okay, and then obviously we're going to add all those up. Okay, so it's going to be 48 plus 48 plus 102 plus 102 plus 136 plus 136. 572 feet squared. So once again, the 4 points, or the 3 points I mean, be all these areas of each side, the answer, and the units. Okay? Hopefully you're getting what I'm saying here. Hopefully you're getting, if you're ever confused, if you were confused on any of these problems, guys, you need to go back and watch the video. The learning targets are right above all these. So this is learning target 5. If you were struggling with volume, go watch the volume video. It was, last week sometime, so you just have to scroll down a little bit on the Schoology page. If you're still struggling with this, well, then go watch the video, okay? You're not going to get better at it by not practicing. I guarantee that. All right, so number 3 now, finding surface area. Okay, this is where you guys just become, what I said, like robots. You just get in the habit of doing this every time. Front, back, left side, right side, top, bottom, and then you get confused. Okay, don't become a robot. Understand what you're doing. By doing this, we're just finding the area of each face. We're finding the front face. We're finding the area of the back face. We're finding the right face and the left face. And then we find the top and the bottom. Okay? Well, this could be a little different. It depends on what you're going to call it. Okay? This right here, I obviously would call that the front. Now, you could call it whatever you want, really, but obviously front makes sense. So that's, I know there's a front. And since it's a prism, it's being stretched to another triangle back here. I know that there's going to be a back triangle. That's one thing I was going to add too. When it's a triangular prism, by the way, I like to put a little front triangle, back triangle, like that. I just like to do that because it reminds me that it's a triangle, so I must use this formula. Okay, just a little reminder. Okay, so we've accounted for there's 5 sides in this, remember? We've accounted for 2 of them. We got a front and a back. Now's where you're going to have to make some decisions. This side right here, what do you want to call it? Some of you might say, well, I want to call that the right side. Okay, whatever. Some of you might call it the top. Whatever. Okay, I would probably call that my top. Fine. Okay, this side back here, what would we call it? Probably call that the left side, right? So then we have a left side. And then what's the 5th side of this thing? It is the bottom. So then I would have a bottom. Okay. You might have had right side, and you might have these different named a little bit differently. It doesn't matter. The names just help you identify everything. Okay. So again, now before I really start calculating anything, I'm going to put my dimensions on. If I know this is 13, then I also know that this is 13. If this is 14 right here, then I know this is 14. Okay. It's going to be important here in a minute. So first of all, let's find the area of the triangle. So again, you got to use this formula. So it's going to be 1/2 times 5 times 12. Okay, that's the base and the height of the triangle. So that's going to be 30 inches squared. And then the back triangle obviously is going to be 30 inches squared also. Okay. The top, the dimensions are going to be 14 by 13. Hopefully you saw that. So 13, hang on, what was it? 14 times 13 equals 182 inches squared. Please don't just get in the habit of just putting, oh, then that one's got to be 182. No. Triangular prisms are totally different than these. These are always going to have a pair that are the same area. These are not, because there's only one thing being stretched, and that's a triangle. These are the only 2 going to be the same. Okay? Now the left side, okay, over here, well, I know that this would be one side of the left side, and then that would be the height. So the base and the height would be 14 times 5. So 14 times 5 gives me 70 inches squared. And then the bottom, which I will show in this blue right here, would be this dimension right here by this dimension, 12 by 14, 168. And hopefully you're catching your mistake right as we go here. That's the hope, because if you did it this way, you should be able to see, oh, I did, for this, where it's red here, the top, I did 13 times 13 accidentally. Like, you can catch your mistake, I'm hoping. Okay, so now we need to add all these sides up, all the areas up. It's going to be 30 plus 30 plus 182 plus 70 plus 168. It's going to be 480 feet squared. The 3 points, all your work here, the answer, and the units. Remember, area is always squared. Okay? So, at the bottom of this page is going to be worth, let's see here, 1 point, 2 points, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So I want you to put how many you got right out of 11 on that page. Each question was their own individual question, okay? Because you should have been grading it. Let's go on to the back now. Okay? This one here, learn target 2 and 3. Which shape can be formed by this net? Well, I know, realistically, this kind of has 2 answers in a way, and we'll go over both those. I'm going to accept both. Okay? You can see this is the one that reminds me of a banana peel, and I can imagine these things folding up, and these things folding up, and these folding up, and they're all going to meet at one common vertex. That's the very definition of a pyramid, right? So we know it's a pyramid. Now we just got to determine what this shape is. Now realistically, you know nothing about that shape. You don't know if all the sides are equal. You don't know. Okay? So what I'm going to do is I'm going to accept rectangular pyramid, or I will accept, because I'm being nice, a square pyramid. Now, realistically, this is the only answer if you want to be realistic here. Okay? I never want you to call a square unless you know that all these sides are the same length. Okay? But either one, I will accept either one. Okay? Would this net form a cube? Again, guys, this is on the test tomorrow. I'm going to have graph paper. Remember what we did with when I had a little camera, the IPEVO, and I was drawing them on graph paper, and then I was trying to fold them up. That you can use that skill tomorrow. Okay, you can absolutely use that skill. This one would be absolutely yes. Okay, if this one was my bottom right here, this would form the back. This would form the right side. Okay, this would end up forming the front. This would form the top. This would form the left side. Now, some of you might have folded it a little bit differently. There's many. This isn't the only way you could have done it. You could call this the bottom. I mean, it just all depends on how you did it in your mind. But it's absolutely yes. This one would be absolutely no. Okay, you cannot form a cube because you would have 2 sides that would end up overlapping each other. Okay, so again, use graph paper tomorrow on the test, or get it out right now and practice. Okay, last couple problems here. Find the surface area of this tent. Okay, good. So we got to figure out our sides. Okay, this is if we were putting, let's say we were putting wrapping paper around our. All right, so you got to find the surface area. So again, you got to give names to you got to give names to these sides. That's the way you got to do it. Okay. Now, first of all, it says the height is 10, so I'm just going to go ahead and put 10 in there, like that. And then the other piece of information you really need, it really doesn't say it right. It's really wrong. This is 5 right here. This slant right here. This is also 5. So we know this. Both slants of the triangle are the same length. I know that this is 10 feet. Okay, and that's pretty much all you need to know. Okay. So again, I know that this is a triangular prism. So I know that the base shape is a triangle. So I'm going to do front triangle. Again, I do that just to remind myself. And then I have a back triangle. Tells me that I got to do this formula because it's a triangle, okay? So the front triangle is going to be that and that. Okay, now I'm going to call this my right side. I'll call this back side my left side, and then I have a bottom. Okay, so, or you call this the top. It doesn't really matter. Right side, left side, and then bottom. Okay, so the front triangle here, I know it's going to be 1/2 times 6 times 4, right? Base times height, base and height, always meet at a right angle. So that's going to give me 12 feet squared. And I know that's the height because the arrow's drawing it in there. So I know the back must be 12 feet squared. Okay, now I'm going to do the right side. So I know that this is that dimension by that dimension. 10 times 5 is 50 feet squared. I know the left side has got the same exact dimensions. That's not always going to be that way, but it is 10 by 5, which is 50 feet squared. Okay, and then the bottom, which I'll do in this light blue color, would be 6 by 10, right? 60 feet squared. Okay, so we add all these up. We're going to get 12 plus 12 plus 100. I just went ahead and added 50 and 50 plus 60, which is 184 feet squared. 3 points. This work right here, the answer, and the units. All right, last one, volume question. Because it says which one holds more. You know right away this is volume. So this one here, we're just going to find the volume of both of these rectangular prisms. Right, guys? Okay, so I know it's area of the base, shape, times my height. And I'll do the same thing over here. Volume equals area of the base times the distance between the bases. Now, once again, I'm just going to go ahead and call my base shape the front, like where the door of the safe hole is. Okay, you can see they're a little different shape, but if you really wanted to keep, like all your money in there or something, then you would want to pick the one that holds the most. Okay, so I call my front my base shape. Okay, so I know that this is going to be, these are the two dimensions that I should worry about here. So it's going to be 60 by 30. Okay, so I need to find the area. 60 times 30, and that's going to be 1800. And then the distance between the front and the back would be 45. Calculator times 45. It's going to be 81,000 centimeters cubed. Again, the 3 points here, formula, answer, units. Okay, this one here, the dimensions would be 40, because that's 40, by 60, right? So the area of my base is 40 times 60, which is 2,400. Then the distance between the front and the back is 40. So get out your calculator and check that. 2,400 times 40 equals 96,000 centimeters cubed. Okay, so there's formula, answer, units. Which safe holds more, guys? Safe B, clearly. That one only holds 81,000 1 by 1 by 1 cubes, right? This one holds 96,000 of them. So the bottom, this page right here is going to be worth 1, 2, 3, 4, 5. So put what you got out of 5 at the bottom here. How many points? Okay. Now, if you didn't do all this work, it's wrong. You don't even get the points. So the whole thing is out of 16. So I want you at the top now to put how many points you got out of 16. So you just subtract how many you missed from 16. Okay. Guys, if there's anything on here that you know, I do not get volume, I do not get surface area, I do not get nets, you need to go back and watch the video. All right. See you guys.